Okay, chemists, we're going to do some more practice problems for stoichiometry. So remember, when you're doing a stoichiometry problem, the first step is to always balance the equation. Only a balanced chemical equation represents what's really going on in a chemical reaction. So let's go over here, and it says aluminum solid metal reacts with oxygen gas to produce aluminum oxide. So, as it stands right now, we have one aluminum on the reactants and two aluminums on the products. We have 2 oxygens on the reactants and 3 oxygens on the products, so it is not balanced. So I'm going to go ahead and balance this. Remember, there's a video for balancing equations if you don't remember how to do that. So the real representation of what's happening here is that there is 4 atoms of aluminum reacting with 3 molecules of oxygen to produce 2 formula units of aluminum oxide. Remember, an atom is a single piece of an element, a molecule is a single piece of a covalent compound, and a formula unit is a single piece of an ionic compound. So this allows me to see this mole ratio. So the mole ratio is 4 moles of aluminum to 3 moles of oxygen to 2 moles of aluminum oxide, like such. So I'm just going to come up with a couple problems for us to walk through together. Let's say 128.6 grams of aluminum reacts with how many grams of oxygen? So here's an example of a problem. The next step that I want to do after balancing the equation is to find my given. The given always comes with the numbers. So I'm going to use not just my given with the numbers, I'm also going to make sure I have units and labels. This is going to keep me from getting lost. The next step is to diagram the equation. So I'm starting with grams of aluminum, and I'm ending with grams of oxygen. So I'm going from grams of one to grams of another. So that would be starting with mass of A and ending with mass of B. Remember, in Stoic problems, we're always going to start on the A side, regardless of whether you have 2 reactants, 2 products, a reactant and a product. We're just going to start on the A side. The given's going to be A. What they're asking us to find is going to be B. So in this case, A is aluminum and B is oxygen. So now I'm going to make a plan. That means that I'm going to start with mass of aluminum. I cannot go straight from mass of aluminum to mass of oxygen. There's no arrow that takes me straight here. So first I have to go from mass of aluminum to moles of aluminum, then moles of aluminum to moles of oxygen, then moles of oxygen to mass of oxygen. So let's make our mole map plan. And I'm going to see that I have 3 arrows that will represent 3 conversion factors. So this will be a 3-step problem. So now I'm going to do my dimensional analysis. That means I'm going to change grams of aluminum to moles of aluminum first. You'll see when I change grams of aluminum to moles of aluminum, in between the box that says mass A and moles A, it tells you use the periodic table of the elements. I'm going to see the pattern. Remember, this pattern every single time is going to be the same. The units will always go like that so that we're canceling out. So my units of grams of aluminum go here. And I'm going to change it to moles of aluminum so it goes up here. So the conversion factor tells me the word mole gets a 1. Remember, we're not going to make the mistake of thinking the 1 is always on the bottom. Grams, anytime you have the units of grams, you're going to look to the periodic table of the elements for these conversion factors. Like such. That cancels out my grams of aluminum. I'm now going to change moles of aluminum to moles of oxygen. This is where it becomes very important that we're using units and labels, because I just said moles to moles, I wouldn't know which numbers go where. But if I say moles of aluminum to moles of oxygen, I will know which number goes where, because it tells me to use the coefficients from the balanced chemical equation. The coefficient for oxygen is 3. The coefficient for aluminum is 4. This lets me cancel out moles of aluminum. I'm now in moles of oxygen. So the next step is I can change moles of oxygen to mass of oxygen. I'll put moles of oxygen down here to cancel. And I'm going to put grams of oxygen up here. That's what I'm looking to find. Conversion factor. The periodic table of the elements always tells us how many grams there are in 1 mole. For oxygen, it's O2, so I have to be careful. It's not 16, it's 32. Now, in my calculator, I'm going to multiply across the top and then divide by the bottom. So I take 128.6 times 3 times 32.00. I'm going to divide that by 26.98 times 4. And I get an answer of 114.3958. Your calculator is going to give you lots of digits. But I'm going to look to my given to figure out how many sig figs. My given has 4 sig figs, so I'm going to answer to 4 sig figs. My reported answer will be 114.4 grams of oxygen. All right, let's do another problem with using the same balanced chemical equation. This time our problem states 8.94 times 10 to the 24th molecules of oxygen will produce how many grams of aluminum oxide? Remember, first step is to balance the equation. We already balanced it. Next step is to pick your given out. Given's the one with the numbers, 8.94 times 10 to the 24th molecules. So this time I'm going to diagram the equation. I'm starting with oxygen and I'm ending with aluminum oxide. So I'm starting with molecules. Remember, we always start on the A side. And I want to end at grams. So in this case, oxygen is compound A and compound B is aluminum oxide. So let's make a mole map plan. We'll start with particles of oxygen. We'll change that to moles of oxygen. Moles of aluminum oxide. And then grams of aluminum oxide. So again, I have 3 arrows 3 conversion factors, 3-step problem. Mass to moles, moles to moles, and then moles to grams. So let's go ahead with our first step of the problem. Step 1 right here tells us we're changing particles to moles. So I'm going to put molecules down here so it cancels. And I'm going to change it to moles. If I look at this conversion factor here, you'll see the number 1 goes with moles. And this number right here, this big giant number, goes with anything in that particles box. Molecules is acceptable. To put 6.02 times 10 to the 23rd molecules. Now I've canceled out molecules, and I want to change moles of O2 to moles of aluminum oxide. I need moles of O2 to cancel, so I'm going to put that on the bottom and moles of aluminum oxide on the top. I go to my balanced chemical equation, and 3 moles of aluminum produce 2 moles of aluminum oxide of oxygen. And now I can change moles of aluminum oxide to grams of aluminum oxide. So periodic table of the elements is where I get my grams, and it always tells me the number of grams in 1 mole. Now I have to add up the molar mass of aluminum oxide at 26.98 plus 3 oxygens at 16. And I get an answer of 101.96. Now I cancel out moles of aluminum oxide, and I'm all set up because my answer that they asked me for was grams of aluminum oxide. So in my calculator, remember, I have to use my exponent function. So I'll type in the numbers 8.94, and then I'm going to find my EE key. And I'm not going to use the number 10. I'm not going to use the caret sign. My calculator knows what it means when I tell it I'm doing an exponent number. Then I'm going to press times 2 times 101.96. I always press enter. But with your new calculators, if you want to do it all in one step, you can. Then I'm going to press divided by, parentheses, 2 EE23 times 3. And I get an answer of 100.9438, so on and so forth. I'm going to round that to 3 significant figures because of my given. And I get 101 grams of aluminum oxide. And that's what I would report my answer as. There's another couple examples of stoichiometry problems for you to try to understand the concept.